Hi, this is Sam Wilker with ThinkParticle.com, and in this video we're going to be talking about the TP Toolkit. This is the visual documentation series, and in this video, or actually you can, before we talk about this video, you can find the TP Toolkit, which is a Thinking Particle Toolkit plugin for Cinema 4D on ThinkParticle.com. It's this great tool that allows you to use thinking particles without actually having to ever touch Espresso. And you can do a lot of complicated things. There are some things you can do without in this toolkit that you can't do anywhere else without rigging it up in Espresso. So there aren't any other tools or plugins that do these things. So that's why I built it. And one of the reasons was like using MoGraph objects to control a lot of different parameters natively and not having to set it up every time manually. So that's why we've built this, and you can check it out on thinkparticle.com. So go ahead and get your copy and open it up, and you can find the TP collision emitter right here, which is what we're going to be talking about today. So we've talked about a few other emitters in other videos, like the simple emitter, which is this emitter right here shooting out particles at this plane. And then we have our collision emitter. And what happens here, as you can tell, is when these particles emit, they hit the plane, and then they'll emit particles from that point where they collide. So if we actually use a value of 180 instead of 45, it'll probably be a better example. And add a few more particles to it. Okay, so every collision now has this little explosion right where it hit. So just like that. Great. And adding some variation in the speed allows you to have a bit more of a, I guess, dynamic look. Adding gravity would be great too. You can also check the box so that the parent particle will die on collision. So we don't cover funeral costs, so just keep that in mind. So to get this set up, you need to go to Simulate, Thinking Particle Settings, or Thinking Particles, Thinking Particle Settings. And then you're going to need to set up your thinking particle group, which is the parent particle group. So this is basically the parent group is like the emitter group. What do these get emitted from? Emit from? What emits these? And then we need a collision object. So when a particle will collide with an object, it will take that particle group and that object, and it will calculate the point and the normals and everything where that hit, and then it will emit a particle or a number of particles based off of that. So it will emit into the TP collided group, which you set up right here. Then you can say how many particles you want per second. So say you want 150, you'll get just a few, and it's great for raindrops or something like that. You can have a ton. You can really crank these numbers really as high as you'd like. So you can get a lot more particles for an interesting MoGraph effect. Then you have your life of your particles. Right now it's set to 15. If we add a little variation, I think it'll look a lot better. There you go. It looks like little splashes. If you add the dynamics object from the plugin, which we'll talk about in another video, you can add some gravity, and that'll help with raindrop looks. And then you can add speed based off of how fast these particles fly up from that point from where they hit. So 100 is a good number. If you set it to 2,000, it's pretty big. So these are just things to think about. It depends on your purpose. 2,000 would be a great number for a rocket explosion when you're dropping a number of bombs or something like that in a visual effects project. Speed variation, again, is just varying the speed. And then the X and Y FOV is just a direction variation. So if we set those both to 0 and then hit play, you'll notice that these particles just go straight up, okay? Which actually looks pretty cool. It's kind of like a water show, actually. So if we set it to, say, 30, then these are going to have a little bit more variation. If we set it to 90, again, a little more variation. So one thing I like to do is set it to 180, and then this basically will just emit along that surface, along the plane. You could turn these up much higher and just have a sphere if you just turn them up both to 360. So now they're emitting in circles based off that point, which is fine. You wouldn't see anything rendered below the plane, but I think it saves calculation speeds to go to 180, and it really depends on what you're hitting with these particles. So then you have your collision settings, and this is very handy right here. One thing you can actually do is the parent die on collision. You can turn that off, and we're going to start actually at the bottom of this list. by going to event only. And then these particles will collide, but they actually won't bounce or hit or slow down. So it's just when these go through. So say you have a plane that represents like this portal effect, and you want to have this circular explosion. And you can use what you can do for that is, say you have particles go through this portal, like particles that would be like a bullet going through a portal. And then you can use a turbulence FD simulation to simulate that ripple explosion look. And that would create an opportunity to create something that would make a great displacement map for compositing or something like that. Then you have your collision type. So let's say we are colliding with a cube, and we'll make it editable. Okay. And we're going to, drag that in to the collision object, and then just hide the plane. Now the particles are bouncing off. Okay. We want to turn it to event only. And you'll notice that the particles, as we turn the speed up, we're going to make the cube an X-ray object. So you'll notice that the particles are getting hit on the inside. So what if we just set it to just front on the collision type? Then they'll only emit on the front side. And if you do the back, then it'll only go on the inside of a plane. So if that doesn't make sense, I'm going to talk a little bit briefly about normals. So if we click on this object down here, you'll notice that we have normals. And these are the lines that point off of these objects. So if we reverse the normals, you'll notice that they point on the inside, and that's just how 3D animation works. Every object has their normals on the polygons. So if you have it set to the back, it will do the back side of a polygon and only emit there and collide and such. And if you have it set to the front, it will only do the front side of a polygon. So if you emit only on the back side and you have a lot of particles go into an object like this, they'll be forever stuck in that, and that could be a cool effect. But if you set it to two-side and event only, then every time they pass through the object on the outside and on the inside, they'll emit particles. And then you have your bounce, and then actually let's talk about offset first. So you have your particle size, so that's relative to the actual size of the particle, which is a size setting that isn't covered in this right here, but it is covered in the dynamics object. So when these collide, it will take the size of the particle and offset them. So if you set it to user-defined travel, though, say 100, they won't even ever get there because they're 100 units away from it, or 10. There's an actual force field for it. It's keeping it away from it. And then you can add some variation. You could set it to 100%, so some of them will collide with the actual object, and some of them won't even make it. So that's the distance from the plane. So we're going a little fast for visualization purpose. There you go. Okay, and then you have your bounce, and this is the amount of bounce that these particles have from this object, the speed that will be inherited from the bounce. So if you set it to 10, they'll move away really slow, but if you set it to 1,000, they'll fly off really fast. So we'll just leave it at 50. And then you can have some variation to that, which is always nice for a little bit of an effect. I wouldn't usually add 100% variation, maybe more like 10. And then surface, energy, friction, spin, chaos. Those I recommend, in this case, looking through the settings on the help menu. You can find those under thinking particles, which are here. The thinking particle nodes the dynamics, and you go to deflector, parameter. Okay, so we'll just go ahead and look at them really quick. You have surface, which is with hard surfaces or hard particles, the angle of incidence should normally be the same as the angle of reflection. However, this behavior changes when liquids are involved, so you can adjust the behavior using a surface value. A value of 0 reflects the particle normally, while a value of 100% will reflect the particle parallel to the collision surface. So I think that means that when it bounces, it will, instead of colliding, say this is the surface, it goes that way. Instead of going like that, it will go down and then go along the surface. So that's what surface does. Energy, with a value of 0%, all particles will rebound in the same way. The energy of each particle then depends on its speed and mass, with energy values greater than 0%. So I'll just finish reading this one, and the rest you can just read yourself. Particles of high mass or low speed reflect less strongly than those with a mass or with a low mass and high speed. A value of 100% simulates a mathematically correct behavior, taking into the account of particle speed and mass. So the rest of it you can find in here, and then I'm going to cover velocity inheritance. So in this case, we'll just go ahead and rotate. I think we're going to set it from, we'll move it from, that's not really going to work. Okay. -500. Nope, we'll set it to 500. And we'll set it to move to 0. Okay. Now when these particles come over, you're going to notice they're going to bounce. Well, no, they won't, because they're getting caught by this. But if we set the bounce value to 0 and the velocity inheritance return up, they're going to inherit the velocity of the object they collide with. 100% is going to inherit the velocity. So you noticed when it was bouncing, they'd stop at the end. But if you leave the velocity inheritance on and it slows down at the end, the particles are going to keep going with it. So you can see the red particles now fly off. So if we set that to 0 and they bounce to 100, they don't leave. So they might a little bit at the end once the particles bounce off and collide off of this cube, but that's what velocity inheritance is. It's inheriting the velocity of the object. So we talked about the way to set up, how we set up our particle groups for setting up our particles. It's really redundant. So a particle group is kind of like a last name. So it's a group of particles that all take the same direction, the same purpose in their lives. And then you have a collision object, which is where the particles are actually emitted from. And as a particle hits that collision object, it will take the normal of the geometry and the collision, and it will use them to emit particles. And then you have your particles per second. You can set the particles, or you can control the particles and have them die on collision. You can have longer or shorter lives and higher or faster or slower speeds. You can add variation to both of those, and then you have your direction variation for the explosion. So that's what we talked about in this video and the collision settings. And you can go ahead and check out thinkparticle.com to learn more about the TP Toolkit and find the rest of this series. And go ahead and get your copy of the TP Toolkit there now. And I am Sam Welker, and thank you for watching the video. I'll see you guys later.